Alright, so our first step starts off pretty easy. What it states is that you're going to have to assign priorities to the 4 atoms on a chiral center based on their atomic mass in the periodic table. So let's break that down a little bit more. First of all, notice that I underlined 4 atoms. Why specifically is it the number 4? Because remember, the definition of a chiral center was any atom that has 4 different groups. So what I'm basically just saying here is that you find those 4 different groups and you give them priorities. How? Based on their mass in the periodic table. Okay? So let's just go ahead and look at this molecule to kind of get started with this rule. First of all, were you guys able to find an atom here that would count as a chiral center? Because that's always going to be the first step. Locate your chiral center. So do you guys see one? Maybe an atom that's 4 different. Yeah, you found it. It's this one right here. Remember, I can use a star to represent a chiral center. Awesome job. Notice that that carbon has 4 completely different atoms coming off of it. It has oxygen, nitrogen, hydrogen. What's that stick? Obviously, that would be a carbon, okay? Perfect. So we've got 4 different atoms. This is definitely a chiral center. So we've got the first step down. The second step is that we need to assign priorities based on the periodic table. This might be the point of the video that you want to pause and grab a periodic table and then rush back over here. But we could also use this to remember our big 7. So remember that the big 7 is just a method to remember some of the most important atoms on the periodic table. Remember that the way we do this is we just draw literally a big 7. Okay? And then you split the big 7 into 7 boxes. And then we would just fill these out in order of the atoms on the upper right-hand side of the periodic table. So remember that we always start off with carbon, okay? And then we go to nitrogen, oxygen, fluorine. Now we're in the halogens, and we have to go down. So it'll be fluorine, chlorine, bromine, iodine. That's our big 7, okay? Obviously, this isn't comprehensive, but it's a great reference point even for all the other atoms on the periodic table. Okay, so now I'm just going to trust you guys that either you're looking at the big 7 that I just drew or you have a periodic table. Let's go ahead and assign priorities. So my first question to you is, which one would get the highest priority out of these 4 different atoms? Which one is the highest according to atomic mass? It has to be the oxygen, right? Because we said that we have 4 different atoms: oxygen, nitrogen, hydrogen, and carbon. Okay, so this is going to be my number 1 priority because it has the highest weight on the periodic table. Okay? I don't have any of the heavier atoms. So now if that's number 1, which one is number 2? Number 2 has to be nitrogen because it's a little bit lighter. So that's going to get my 2. Which one's number 3? Has to be carbon. So carbon's my number 3. And just so you guys know, if you ever see a hydrogen, that's always going to be your 4. Okay? Because nothing is lighter than hydrogen, right? So you can always just draw 4 there immediately if you just want to get good at it, okay? So that was the first step, guys. It's just look at your periodic table. If you need to, draw your big 7 and go ahead and compare priorities. Not so bad, right? Let's move on to the next step.